Hey guys, welcome to day 2 of coordinate geometry. So just as a quick review of what we talked about yesterday was just what coordinate geometry is, which is, bringing the study of geometry to graphs. And for us, we're going to be focusing on quadrilaterals. So basically it's all about how we can prove that a certain shape is what you claim that it is, and how we can figure out those pieces of evidence, which are parallel sides, congruent sides, and also right angles. So far we've shown how to prove that two sides are parallel. We've also talked about how to prove two sides are congruent. So today we are picking up where we left off there, which is how to prove that an angle is 90 degrees. Okay, so we're proving that there are right angles in a shape. So basically, when you're trying to prove that there is a right angle or a 90-degree angle, you're trying to prove that the two lines that form that angle are perpendicular. And what that means is that they intersect at a 90-degree angle. So in order to do that, what we need to do is find the slopes of the lines in question. And, I've written down here that you should always just find the slope of all sides. You will always have to do that anyway. The point is to identify whether or not slopes fit the bill to be perpendicular lines. So what we're looking for is opposite reciprocals. Now, opposite reciprocals is that vocab word that we talked about last week. Opposite refers to a sign change, so positive versus negative, whereas reciprocals refers to a flipping of the fraction. All right, so let's just do a couple of examples of that. So for instance, if I had a slope of 2/3, the opposite reciprocal of that would be -3/2, right? And this is an opposite reciprocal because I flipped the top and the bottom, and I changed the sign by making it negative because it was positive before. So if I had a line that has a slope of 2/3, the one perpendicular to it would have to have a slope of -3/2. Another example would be if I had -2/1, this would turn into +1/2. Okay, so hopefully that helps you remember what an opposite reciprocal is and what to look for with these slopes. So as I said, the main process is just always going to involve finding all the slopes of all the sides of your shape. So it just ends up coming down to identifying whether you can see opposite reciprocal pairs or not. So let's see what this is going to look like. All right, let's say I have this shape and I want to prove that side AB is perpendicular to side AD. So basically I'm trying to prove that this is a right angle. So I need to come up with the evidence. So what I want to do is go ahead and figure out what the slopes are. So the slope of AD, we're going to go ahead and figure out our rise and run. So we know that the slope of AD is going to be, well, this height here is 3 and it moved up, so it's a +3. And this run is going to be 2 boxes, and it's positive because we're moving to the right. So our slope here is 3/2. All right, and then now we need to figure out the slope of AB. Now here's the thing. You can make your triangles inside or outside. It really doesn't matter as long as you remember that you have to look for the rise first, right? So here the rise is 2. However, it's very important that we notice something. This line AB is going downwards from left to right. We always read a graph like we read a book, right? Left to right. It is going downwards, and the reason is because the rise is actually going down, right? It's downward movement. So we have to make that a -2 instead of just 2. So because it's 2 boxes and it's moving downwards, it turns negative. The run, on the other hand, is still moving to the right, so that's going to stay a +3 because there's 3 boxes. So the slope of AB, it's kind of ugly. The slope of AB is going to be -2/3 because -2 is the rise, 3 is the run. Remember, it's always rise over run. And what I mean by that, by the way, is the up and down movement represents the rise, whereas the left and right movement represents the run. So maybe this is a helpful visual for you. All right, so now we have found the two slopes, and we need to check to see if they're opposite reciprocals. So 3 over 2 versus negative 2 over 3. Well, the fraction was flipped, so it is a reciprocal, and the original one was positive and the new one is negative. So they are perpendicular. So we can say AD is perpendicular to AB. This is actually the mathematical symbol for perpendicular. So we can say that angle A is 90 degrees. And we can say that because the slopes are opposite reciprocals. Oh, my handwriting's kind of ugly here. All right, and that is all you need to do in order to identify whether two sides are creating a right angle or not. In this case, we were able to say that there is a right angle here. All right, so let's do one big practice problem that will represent pretty much what our practice problems for this unit will look like. So let's say we had this shape. I'm going to go ahead and label it. And we want to figure out what shape it is. Hopefully you would look at it and start brainstorming about what you think it could be. And then we will figure out all the information for it and make our decision accordingly. So the first thing you always just want to do for these problems is go ahead and find all of the slopes. So all of the slopes. We've got AB, BC. Let's write this a little nicer. DC, doesn't matter which order the two letters are in, and then DA. All right, so let's see. We have to count our rise over runs. So for AB, we have a rise of this set of boxes. That's going to be a 4. And for the run, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. And we went down though, so this is going to be a negative 4. So our slope for AB is negative 4 over 8. Now we want to simplify this because remember we don't like slopes as non-simplified fractions, so this can actually simplify to negative 1/2. All right, on to BC. And actually I think I'm just going to change the colors here so that it's a little easier to look at. Alrighty, so our BC, we have to count the rise over run again. So let's see. To get from C to B, we have to move up by 8 boxes, and we move to the right by 4 boxes. So my slope here is 8 over 4. But again, with the simplifying fractions, this is not simplified. We can divide both the top and bottom by 4, and we end up with 2 over 1 for our slope. Okay, on to DC. Again, I'm just going to go ahead and choose another color. Should have thought about that at the beginning, but I didn't. All right, so DC, we have a rise. We are moving down this time from D to C. So we have down 4, so negative 4 for the rise. And then we move to the right by 8 boxes, so positive 8. Our slope of DC is going to be negative 4 over 8. Now this again isn't simplified. We can simplify that down to negative 1/2. Finally, we have side DA. And another color. Okay, so the rise here is 1, 2, 3, 4, 5, 6, 7, 8, and then to the right 4, so we got positive 8, positive 4. Slope here for DA is 8 over 4. Again, not simplified, so this turns into 2 over 1. So at this point, we have to go ahead and move to the next step, which is to find all of the lengths. Right now we found all the slopes and we're going to use that information, but we'll use it later, right? So now I'm going to go ahead and find all of the lengths of all of the sides. So lengths. Now this is where we use the Pythagorean theorem. And the nice thing is that a lot of the hard work was already done for us. See how we already made all of these triangles for each of the sides. So now I just have to use those numbers. So for example, for side AB, the triangle has legs 8 and -4. We don't need to use the negative number because if we're just literally talking about the side length, it is 4. We made it negative because we were talking about slope movement. But in terms of the length of the legs, it can be just a +4. But even if you did a -4, it really wouldn't make a difference because we're squaring it. It'll turn positive anyway. So we set up our Pythagorean theorem. This gives us 16 plus 64. And so 64 plus 16 is 80. And that's when we have to square root both sides so that we can finally get C alone. So we find that side AB is equal to the square root of 80. All right, next one, BC. So for BC, we still have legs of 8 and 4. So we would say, okay, well, again, 4 squared plus 8 squared equals C squared. Hopefully you notice that the numbers are the same. So it's still going to end up with 80 equaling C squared, and then the whole side ends up being the square root of 80. And again, now we do DC. Hopefully you notice, same size legs. It's still a 4 and an 8. So it'll be the same thing. Again, we'll get 80. And so we find out that this length is also the square root of 80. One more side. This one, shocker, shocker, still has legs of length 8 and 4, so it'll again be 4 squared plus 8 squared. It equals 80. And you don't really necessarily always have to do all of this work because once you notice that they all have the same exact legs, it's gonna be the same answers because you're literally working with the same numbers. But I just wanted to show you how this whole process looks. All right. So now that we have done all that, sorry, there's a little glitch in the video here, we need to identify what shape it is for once and for all. So let's go take a look at all of our evidence and see if we can gather anything. So the first thing we want to notice is that there are 4 congruent sides. They are all the square root of 80. So we have 4 congruent sides. And what else do we have? Well, we can see that there are parallel sides, right? AB is parallel to DC because they have the same slope. BC is parallel to DA. So we do have, well, we could just say that opposite sides are parallel. But what else we can say is that there are right angles. And the reason I say that is because AB and BC, those are opposite reciprocals, right? -1/2 to 2/1, that is an opposite reciprocal. These two are an opposite reciprocal. These two, and also AB and DA. So like these two, these two, these two, and these two. These are all opposite reciprocal pairs. So we're able to say that there are right angles all of these corners. So we can conclude that there are 4 right angles because of opposite reciprocal slopes. Now, after you gather all of this information, these conclusions that we made, we can then say that, well, it has 4 right angles and 4 congruent sides. This parallel thing is nice, but we should notice that the congruent sides and right angles are enough information to say that it's a square, because that has all of the requirements in order to be a square.